Lesson 5.3 is an extremely important lesson to understand when we study linear equations. And the topic is slope. Slope describes the steepness of lines in the coordinate plane. And that's written right here in your notes. The steepness of line is called the slope. And it's always the vertical change over the horizontal change. The ratio of the vertical change to the horizontal change is slope. And you will often hear it referred to as rise over run. So if you take a look at the graph over here, here's my line. And if I compare points on the graph to travel from this point to this point, I would have to travel up 3 units and right 2 units. So it is this rise, which is 3, and that's on the top, and the run, which is the horizontal change, 2 to the right, right would be positive. So the slope of this line is 3 over 2. What if I went from this point that I started with to this point here? So I would still travel up, so that would be a total of 6 units up, and I would travel a total of 4 units right. So the slope is 6 over 4. If you think about that as a fraction, we can simplify that. 6 over 4 is equivalent to 3 over 2. So the slope, no matter what 2 points you choose, is 3 over 2. What if I went from this point here to this point here? So I would go down 3, and I would indicate down with a negative, and then I would go left 2, and I indicate left with a negative. So the slope would be negative 3 over negative 2, and we should know by now that 2 negatives divided by each other equals a positive. So again, no matter which 2 points you choose, you will always get the same slope of 3 over 2. So let's take a look at the example below. We are asked to identify the slope of each line. So they are kind enough to give us 2 points. Remember, slope is rise over run. Rise over run. So to go from this point to this point, I would draw my triangle. I have to rise first, so that means I would go up 2, and then I run right 3. So up 2, right 3, so the slope is 2 over 3. Up is positive, and right is positive. If we take a look at the next example, to go from this point here to this point here, I would travel 3 up, so I would go up 3, and then I would go to the right 5. So right 5, up is positive, and right is positive, so it's 3 over 5 for the slope. We like fractions for slope because of the rise over the run. If our slope is a fraction, it tells us exactly how many to go up and how many to go over. If we take a look at the third example, I'm going to start here and I'm going to end here. I would rise, but I have to go down. So that would mean it's down 1, and then I would go to the right 4 spaces. So down 1, right 4, Down would be a negative, and right is a positive. So that means my slope is down 1, so negative 1. Right 4 is a positive 4, so my slope is negative 1/4. Moving on, we can find the slope of a line by subtracting the coordinates of any 2 points on the line. So this is a formula that I'm going to teach you. Now we use the letter M for slope, and that is because the person who came up with this, his name was René Descartes. He was a Frenchman, and the French word for slope starts with M. We're going to look at the change in the y values, and the reason is it's the rise. So if I take a look at this point here and this point here, I can see on the y-axis it goes from here on the y-axis to here on the y-axis, and that is the rise. So if you look at the y values are 3 and 0, and you notice that I went up 3 spaces. So it's the change in the y's, 3 minus 0. Now since those are both y's, we are going to have to distinguish them. So I'm going to say this here is the first y, and this here is the second y. So what I did over here is I took y2, the second y, minus the first y here. So in my formula, I'm going to have y2 minus y1. And you can see down here, the 3 minus 0 is the y2 minus the y1. And that is going to go over the change in the x-coordinates. So if you take a look at the x-coordinates, I'm looking here and I'm looking here. My x-coordinates are 2 and negative 4. My x-coordinates are 2 and negative 4. And that is how much I run. So I'm going to call this my x1, my first x-coordinate, and this one is going to be my x2, which means the second x-coordinate. So here you can see that we did the x2, negative 4, minus the x1, which was 2. So the formula, x2 minus x1. This formula right here is very, very, very important for you to know. All right, so let's take a look at some examples here. What is the slope of the line that passes through each pair of points? So you must do this. You must, above each point, put x1, y1 and x2, y2. So off to the side, I'm going to say x1 equals negative 3, y1 equals 2, x2 equals 2, and y2 equals 4. So my equation for slope is m equals y2 minus y1 over x2 minus x1. So the slope is going to be y2, which I said right here was 4. So instead of y2, I'm going to put 4 minus y1, which right here says y1 is 2, so I'm going to put in a 2 there, over x2, which it says right here is 2, minus x1, which is negative 3. And now it's time for me to simplify that. Well, 4 minus 2 is easy enough. 4 minus 2 is 2. 2 minus negative 3, some of us haven't gotten this yet. Minus a negative, that's the keep, add, opposite, K-A-O. So we have keep, add, opposite. So now we have 2 plus 3, and that answer is 5. So the slope of the line that contains the points negative 3, 2, and 2, 4 is 2/5. Let's continue on with part B. So like I said, above each one you're going to put x1, y1, and then you're going to put x2, y2, and I might come off to the side here. So x1 equals 6, y1 equals 1, x2 equals 8, and y2 equals negative 5. And I got those values because I plugged, or I put x1 is 6, y1 is 1, x2 is 8, y2 is negative 5. That's where I got those. Now I'm ready to plug it into this formula. So I'm going to write the formula down. M equals y2 minus y1 over x2 minus x1, and I'm ready to plug numbers in. So the slope equals negative 5 minus my y1, which is 1, over the x2, which is 8, minus the x1, which is 6. Now it's time to simplify. Negative 5 minus 1 is negative 6. And 8 minus 6 is 2. And the slope, negative 6 over 2, will equal negative 3. So that is the slope of the line. Let's do this last one. I'm going to do it in the same manner. So x1, y1, x2, y2. So over here I'm going to say that x1 is equal to negative 2, y1 is equal to 4, x2 is equal to 1, and y2 is equal to 4. And again, I got those by putting them right on top of each other. x2 is right here, that's 1, and y2 is 4. So let's plug it into the formula. The slope is equal to y2 minus y1 over x2 minus x1. We're ready to plug numbers in. So y2 is 4 minus y1 is 4 over x2, which is negative 2, minus x1, which is, x2 is 1. Let's fix that. x2 is 1 minus x1, which is negative 2. So we're ready to simplify. 4 minus 4 is 0. And 1 minus negative 2, again, that's keep, add, opposite, K-A-O, and that equals 3. And 0 divided by 3 is 0. So the slope of this line is 0. This next page